In this video, I'll show you how to simplify expressions using trigonometric identities. This is part 1. Starting off with question 1, they ask us to simplify the expression cosine theta over secant squared theta. Secant squared theta is a reciprocal trigonometric function. So we have secant is equal to 1 over cosine theta. What I can do is replace secant squared theta with 1 over cosine squared theta. If I do that, I'll continue my answer here. I have cosine theta, the numerator doesn't change, and at the bottom we have 1 over cosine squared theta. Rearranging this quotient, we have cosine theta, the top part, divided by 1 over cosine squared theta. Remember, cosine squared theta is the same thing as cosine theta squared. That being said, if I continue on with this division, we take the reciprocal of the second fraction and this turns into multiplication, where we have cosine theta times cosine theta squared over 1. Cosine theta times cosine theta squared gives us cosine cubed. And this term is the simplified version of what we had originally, shown here. In question 2, they say simplify the expression so that it contains only sine and cosine. You'll notice cotangent. Cotangent is the reciprocal function of tangent. Also, tangent is defined as sine theta over cosine theta. Those are two known facts. So what I'll do is replace cotangent theta, the term that's in the numerator, with 1 over tangent theta, and the denominator cosecant theta is actually the reciprocal function of sine theta. So I'm going to replace this with 1 over sine theta as well. Now, because the question wanted it in cosine and sine, this tangent needs to be replaced with that. So we have sine theta over cosine theta. Hope you're following along here. And secant theta is equal to 1 over cosine theta. The only problem right now is this tangent, and we can actually replace this tangent with sine over cosine. Technically, you would have 1 over sine over cosine. 1 over sine over cosine is cosine over sine. So I'm going to replace this whole thing with cosine over sine. Now I have an expression that is purely in sine and cosine, which is what I wanted. I'll start off with this. Simplifying that, you have cosine theta over sine theta being divided to 1 over sine theta. When you divide fractions like these, the second term here, you take the reciprocal of, and this becomes multiplication. This will cancel out, and this whole term goes to simply cosine. Now let's evaluate this part. We have sine over cosine being divided to 1 over cosine. Once again, I'll flip this and change the symbol to multiplication. And this leads me to cancel out the cosines, leaving me strictly with sine. And I can now place this sine right beside the cosine where it belongs. And this complicated expression, what we started with, has suddenly become this thing. So there you have it. That is how to simplify expressions using trigonometric identities. Make sure to watch part 2 for some more examples.